Okay, so let's go to the last part of section 3.6 chain rule. And for here, we're going to look at a very common case involved with the power rule. So it's chain rule with power rule. And the idea is, if you have a composite function, again, U stands for the inside function. It can be a function of x, okay? So when you make a substitution, you can rewrite your function as u to the power of n. And we know that if we take the derivative of capital F with respect to u, the intermediate variable, we're going to apply the power rule equals n times u to the power of n minus 1. Now, of course, the derivative of u with respect to x is itself. So when we try to figure out df dx, which the final result is going to be n times u to the power of n minus 1 times du dx, okay? So let's look at one example. It's very easy to understand. So you see that, guys, this is a composite function, but the big picture, do you see it's something raised to the power 11, right? So in our problem here, u is the inside function here. So which is u equals x cubed plus 4x plus 7, right? And following this, what we can do is df dx, and of course n here equals 11. Equals what? Equals 11 times x cubed plus 4x plus 7 to the power of 10, which is n minus 1, multiply du dx, which is the derivative of the inside function, which is 3x squared plus 4, okay? And that's it. That is the chain rule with a power rule. So it's very straightforward, okay, guys? You can always, replace this part with u. It gonna becomes into u to the power 11s, and then repeat what we introduced in the second part. But as you can see that this overall is in a raised to a power format, so you might want to understand this, and then we actually can use this result to write the derivative result very easily. Okay, so this is chain rule with power. Now let's look at the last example here, like this. So see that if we have a function x squared plus 2x squared, and then times 4 sine x plus e to the power of cosine x. Okay. So this problem is a little bit complex. Why? Because you see, if I block this part, and you can see this is a composite function. We're going to use the chain rule, right? With the power rule we just talked about. But if we block this part, and also you can see that the derivative of 4 sine x easy to handle. The derivative of e to the power cosine x, which you're going to use a little chain rule, right, to handle that. But right now, do you see that the big picture of this function, which is a product of two functions, right? So if we want to figure out, okay, what is df dx? Okay, so to start with, we need to apply product rule first, okay? That is very important to know that, because the overall structure is a product of two functions. This is a composite function, still a function. This is a function involved with a composite function, still as a function. So it's a one function multiply another one. So product rule first. So let's do that. So the derivative, right, in this way, times this, right? This is the product rule, plus e to the power of cosine x, plus x squared plus 2x squared times the derivative of the second function. Okay, so that's the product rule. And to handle the derivative of this, let me write it here. We just learned the chain rule with the power, right? So we can write it as 2 times x squared plus 2x to the power of 1 times the derivative of inside function, which is 2x plus 2. Okay? And then multiply this. 4 sine x plus e to the power of cosine x. Okay. And then plus x squared plus 2x squared, right? Copy this part times the derivative of this, which is gonna be the derivative of 4 sine x give us is 4 cosine of x, and then plus the derivative of e to the power of cosine x, which is e to the power of cosine x times the derivative of the inside function, which give us is negative sine of x. Okay. The answer is kind of long, but from this example, I just want to show you that all the derivative rules we learned before, like the power rule and product rule, quotient rule, they can all put together with chain rule. Okay, so when you have a problem asking you to figure out the derivative, make sure that you clear about the structure of the given function. Is it a product format? Is it a quotient format, right? Or is it in a powered form? And then after you identify that, and then you can move on. Okay, so this is the last part of section 3.6, and it's a long section, but it's a very important section, and I hope you can really work on some problems, from the worksheet I gave or the homework list I gave, and then make sure that you practice some problem, because chain rule, you have to get that click. Okay, you really have to. But how to get that click? Well, you have to practice. So I'll stop here, and then I'll see you in section 3.7. Okay, have a good one, guys.